You're watching the Weiss channel. Dun, 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 dun. Intro to Advanced Math. Today we're going to do the Chapter 6 test review. Okay? So, I've given you a packet of 4 pages. Would you please look at the first page? Central Tendency Revisited. Number 4. Okay? Number 4. It says find the mean, median, mode, minimum, Q1, Q2, Q3, max, and best method of central tendency and draw a box and whisker. Whew. Okay, number 4. All right. Here are your numbers for number 4. Okay, let's create a box and let's do this first. When we find Q1, Q2, and Q3, first thing we do is cut it in half. How many numbers are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 12 numbers. What is halfway? Halfway is 6 numbers. 1, 2, 3, 4, 5, 6. Okay, so here is Q2. What's another name for Q2? Median. Very good. Okay, median. This is the median. So, your Q2 or your median is what? If this is 14 and this is 15, 14.5. Thank you, Shalea. 14.5. Now, to find Q1, we take these 6 numbers and cut them in half. Okay? 1, 2, 3. Here's your halfway point right here. Okay? Right? This is Q1. Yes, 10.5. Good. Okay? Now, we take these 6 numbers, cut them in half. Okay? Very good. Right here. This is your Q3. Okay? 17.5. Okay? So now, how do you make a box and whisker plot? Here's what you do.
Do a number line.
Do a number line.
7 to 21.
That's what we're going to do. 7 to 21. I'm going to start at 7. 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. All right. Now, what is your minimum? Your minimum is 7. Put a big fat dot on 7. What's your maximum? 21. Big fat dot on 21. What is your Q1? 10.5. Put a bar on 10.5. Q2, 14.5. Put a bar there. 17.5. Put a bar there. And close your box. Then draw your lines. Thank you, Shalea. That is your box and whisker plot. Okay? Next, it says, what's the mean? What's the mean? How do you find mean? How do you find the mean? How do you find mean? Add up all the numbers and divide by how many there are, right? So, what's the mean? Mean is, all right? You got 15.1? 14.1? How did you do that? Did you add up all the numbers? So you added up all the numbers. 7 plus 8 plus 10 plus 11 plus 15. Can you tell me what you got when you added them all up? You can do 15.1 times 12. That'll give you the same thing. All right.
181.
What?
181.
181, and you divide it by 12. And 181 divided by 12 is 15.1. Could you check that? 181 divided by 12? 15.1. That's your mean, okay? What's your median? Could you write that down? If you don't have 15.1 for the mean on number 4, would you write that down, please? unless you're going to enjoy watching this video later. Okay?
I got 14.1.
I'm about to say, I
Oh,
did too.
was it 14.1? Sorry.
I got that.
14.1. Fix that. Write 14.1. Okay. Is that right? Did you double check? Okay. All right. 14.1. What's the median? What's the median?
14.5.
14.5. Write that down under median. What's the mode?
17.
17. That's the number that occurs the most, right? Mode, most, right? All right. What is the range? How do you find range? How do you find range?
Add the highest.
Not add.
I mean, subtract the highest.
The highest
7.
minus the lowest. 21 minus 7
14.
equals 14. That is the range. Okay? Now, what's your minimum? 7. Write 7 for min. What's Q1? No. Q1. 10.5. What's Q2? 14.5. What's Q3? 17.5. What's your max? 21. Okay? Now, with all of these numbers relatively close to each other, what is the best measure of central tendency? Mean or median? I need you, seriously, this is your test, right here. Here it is, okay? Answer my question. Mean or median is the best measure of central tendency? Mean, okay?
Because the numbers are close.
Because the numbers are close together. Write that down. Number 4, okay? Mean, right? Mean because the numbers are close together. Write that down, okay? Now look at number 6, please. Number 6, okay? We're going to create a box and whisker plot. We go from 9 to 197. What? Okay. How are we going to do that? Here's how I'm going to do that. I'm going to go
I did about 10.
tens. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. 10, 20, 30, 40, 50, 60, 70, 80, 90, 200. Okay? Okay. Now, where's your Q2? There's 12 numbers again. 1, 2, 3, 4, 5, 6. Between 18 and 18, that's your Q2.
18.
Or your median, which is 18. What is your Q1? Go 1, 2, 3. There's 6 numbers here. What's halfway? Between 12 and 15. How do you find the middle of 12 and 15? Take 12 plus 15 and divide by 2. 12 plus 15 is 27. 27 divided by 2 is 13.5. Okay? That is your Q1. Q1 is 13.5. Okay? What's your Q3? There's 6 numbers here. 1, 2, 3. Here's your halfway point. Between 22 and 23, 22.5. Okay? So now, that's your Q3, right. We're going to draw a box and whisker plot. What's your minimum? 9. Put a dot on 9. Q1 is 13.5. It's somewhere about here, right? Q2 is 18. It's about there. Q3 is 22.5, about there. Close your box. Where's your
197.
197 is your max. Okay? Do your whiskers. That is your box and whisker plot. Okay? Now, what's your mean? Add up all the numbers and divide by 12.
32.
Exactly 32?
Yeah.
Mean is 32. Write that down on number 6. Mean is 32. Okay? What is your median?
18.
18 is your median. What is your mode? 18. The number that occurs the most. 18. What is your range?
188.
Range is 197 minus 9. 188 is your range. Okay? What's your minimum? 9. What's your Q1? 13.5. Q2, 18. Q3, 22.5. Max, 197. Okay? Is in this case mean or median your best description of the data set?
Median.
Median. Why is median?
Because 197 throws it off.
Because 197 throws off the mean. All right? Your answer is going to be median. 197 throws off the mean. Okay? That's why median is your answer in number 6. Okay? Turn the page, please. Okay? Number 10. Box and whisker plot. All right? What is your minimum? 12. Write it down. Number 10. Q1. What is your Q1? 13. Write it down. What is your Q2? 16. Write it down. What is your Q3? 18. Write it down. What is your max? 21. Write it down. What's your median? 16. What's your range? 9 is correct. How do you find the range? 21 minus 12. 21 minus 12 is 9. That's your range. Okay? Turn the page, please. On the back, go to the back of this page. Go to the back of the page. Number 21. What is used to measure how far data values are spread around the mean of a data set? Standard deviation. Remember that. Standard deviation. If you don't have that written there, write it down. Number 21, standard deviation. Number 22, if the data set has a high standard deviation, then the data points tend to be close to or farther away from the mean. Farther away. If you have a high standard deviation, the data points are farther away from the mean. Okay, circle that. Turn the page, please. Let's look at normal curve. Okay, normal curve. Number one, there's 1,200 students, okay? 1,200 students. Mean is 100, standard deviation is 15, okay? So, $1,200 students. Mean is 100, standard deviation is 15. First, we're going to fill in the box. What's the mean? 100. What's plus 1 standard deviation? 115. Plus 2 is 130. Plus 3 is 145. How do we get that? We added 15, the standard deviation, to each one. What's minus 1 standard deviation? 85. That's minus 15. Minus another 15, you got 70. And this one is 55. Okay? Okay. Letter A. What's the percent that the random number is between 100 and 130? That's here. Here's 100, here's 130. What percent of the population from 100 to 130, would you agree that that's 2 standard deviations, right? So I gave you a percent that's within 2 standard deviations, right? But that's not just 2 standard deviations to the right, but it's also 2 standard deviations to the left. This number goes from here to here. So we're only asking from here to here, halfway. So if the whole thing is 95%, okay, what's this piece? 47.5% is the answer to letter A. Okay? Write that down if you don't have it written down. What's the percent that the random number is greater than 115? That's right here, okay? Remember, I gave you 68% is within 1 standard deviation. Either plus 1 or minus 1 standard deviation is 68%. If this whole thing is 68%, what is both of these added together? Both of these added together is 32, right? Because 68 plus 32 is 100%, right? So if this is 68%, then this is 32%. But I only want on this side, right? So this is 16%. Letter B is 16%. Please write that down. Okay? All right. What is C? Percent that the random number is less than 100. 100 is the what? 100 is the mean. What percent is less than 100? 50%. That's half, right? Okay. Letter D. Letter D says how many students. It doesn't say percent. It says how many students are between 70 and 130. Between 70 and 130. Well, over here, once again, between 70 and 130, we're going to deal with the 95%, right? So, what do we have to do? We have to take 1,200 students times 95%, right? We want to know what's in this area here. This area is 95%. 1,200 students times 95% gives you what? 1,140. That is letter D. Okay? Letter E says how many students greater than 70? This is the most complicated question on the test tomorrow, okay? Here's 70, all right? Now remember when we said less than 100 was 50%? Would you agree that greater than 100 is also 50%?
Yeah.
See my orange marks here? 50% over here, greater than 100. And what piece is here greater than 70? Remember this number over here? Between 100 and 130? That was the 47.5%. Wouldn't that be the same number in this area here? Does it make sense then that this piece here in green is the 47.5%, and in orange is the 50%, right? Okay? Add those two together, and what do you get? 97.5%, right? Right? But we need to know how many people. How many people? Well, we got to take 1,200 times 0.975. That's 97.5%. When you do that, you get what? 1,170? That's the answer to letter E. Write that down if you have not written that down. Okay? Would you please turn the page? Okay? Look at plot C and plot D. You see plot C and plot D? Number 5, which plot has the higher median? In fact, what's the median for plot C?
95.
No, what's the median? 67 is the median for plot C. What's the median for plot D? 95. Which has the higher median? Plot D. Please write that down for number 5. Plot D. Okay? Would you look at plot C again? What's the range for plot C? You take what? 90 minus 36. 90 minus 36 is 54. What's the range for plot D? You take 98 minus 90. What do you get? 8. Which has the lower range? Plot D. Put that down for number 6 if you haven't already. All right. What is another name for lower quartile, by the way? What's another name for lower quartile? Q1, right? Q1. Wasn't Q1 the lower quartile, right? What's another name for upper quartile? Q3. Isn't Q3 the upper quartile, right? Okay. Now, plot C. What is the lower quartile? 45. Please write that down for number 7 if you haven't already. Number 8. What is the upper quartile for plot D? 97. Please write that down for number 8 if you haven't already. Number 9. Is that normal, skewed left, or skewed right? Skewed left. Please write down skewed left. Not just left, skewed left. Okay? Number 10. Skewed right. Please write down skewed right. Okay? I can't give you full credit if you don't write skewed right. Number 11. Number 11 is skewed left, skewed right, or normal? Normal. Okay? Write down normal if you have not already for number 11. Okay? Okay. Number 15. How would you expect the variation to differ, high, moderate, or low, between the speed of cars when there's a speed camera present? If there's a speed camera, do you think, what would be how would the variation differ in the speed of cars? It would be low. Why? Because no one wants a ticket. Please write that down for number 15. Number 16. How would you expect the variation to differ, high, moderate, or low, between the speed of cars when there's not a speed camera present? High. Why? Because some people are crazy drivers, right? You have to write that. Because some people are crazy drivers, and some are not. Okay? Number 17. How would you expect the variation to differ between distances athletes jump in the long jump in the Olympics? In the Olympics, there's a tiny variation between the winner and second place, right? How would you expect the variation to differ? Low. Okay? Because Olympians, what? They win by the narrowest of margins, okay? You have to write something like that. Something along those lines, something like that. How would you expect the variation to differ between the distances that classmates jump in the long jump in gym class? That would be a high variation, okay, because some people can jump far and some people can't jump very far at all, okay? You have to write that to make sure I understand what you're talking about. You've been watching the Weiss channel. Da 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 da.